Hello, it's Steve, and this is Brainless Raider, a puzzle adventure game made in 3 hours for Trijam 276. In this series, we're going step by step over the process of remaking the game in Bevy, the Rust game engine, in probably closer to 3 months. Last time on this project, we got a little bit of basic movement going, very basic, very basic. This time, we're going to make this a little bit more functional. Just as a review of how we're doing this is our function for basically setting the scene. Here we spawn all the tiles, and then down in the objects, what we're doing currently is checking the object type against the name. So if we go and we look into tiled real quick, as we click on some of these objects, up here the class is exit, goblinoid, treasure, etc. So that's what we're currently checking. But if you look at this is clearly just going to be very obnoxious eventually. So instead of this horrible mess, let's find a better way. And we're going to start this in tiled talking about something we're not going to do. This was the original plan for how I wanted to implement components on these objects, but it had some complexities that I didn't want to deal with for a project of this size. And I'll talk about why I decided on going a different way later. First of all, let's click on our goblinoid here and add a property. And it would be really nice if we had a little option in here for mover, so that we could click it and do that, and then anything that had a mover would have the mover and also direction X and Y automatically. Well, it turns out we can do that. If we go into the custom types editor here, we can add a class and call it mover. And we can actually add members, and there we go. We could even get even fancier than that and make a vector type, and then use the vector type inside of this mover, which would automatically associate it as a vector. That's nice and fancy and all that. So like if we go in here to this goblinoid, right, and we can add a mover now, call it whatever we want. And now, look at that. It's all encapsulated in its own thing. We know that it has a mover property, and in our code we can check for mover and apply the mover component to it. The issue with that I was running into theoretically is that first we would have to do that process for every single component, and even in a simple project like this, we're going to have a decent number of components. If I had to guess, somewhere in the realm of 10 to 20. And that's not going to be too bad to add, but it would get a little bit obnoxious to maintain those in both sides and have to check to make sure things are named right and all of that. But yeah, so maybe a cool side project to do if this series is too slow for you. Maybe you want to go off on your own for a little while. You can try and figure out how to export these components. So something like a tiled export flag to add on here that would automatically export these as XML, and if you can reference the tiled documentation for their import functionality. But if you had something like that, what you could do is go into the custom types editor and actually import from a XML file. And that would be awesome. That I was halfway through designing something like that, and then I decided, you know what, that's too complicated for what we're doing in this project. Not going to be doing that in this series, but that's a cool solution. Okay, so that's enough talking about a solution that we're not going to do. How are we actually going to solve this? Well, the simplest way that I can think of that would work pretty well for this simple project would add a components property, and actually that's the wrong place. I want to add that in the template itself. A components property with mover and goblinoid in this case. And this identifies which components this has. So goblinoid isn't going to need any direct properties, but mover is going to need X and Y, so it can directly call these X and Ys. The complexity here is that we're going to have to make sure that none of our custom properties for any of our components overlap. So say if we had a teleport exit direction and a mover, so something that had both a mover and a teleport exit, we wouldn't know which direction, which one of these XYs are referring to the direction of that the teleporter is moving, and which one is referring to the direction that the teleporter spits you out in, right? So that ramble might not make much sense unless you've actually played the game jam game that this is based off of, but I'm sure it'll make sense in a few episodes when we get to teleporters. Luckily, this project doesn't have any moving teleporters, and even if it did, we can just name the X and Y a different thing, say teleporter dir X and Y, for instance. Now, I believe I've over-explained that enough, so I'm going to real quick go through all of these templates and add a few components that I think we might need, even though in this episode all we're going to use is the mover one. So, be right back. Okay, so here's a few components that have been added to all of these templates. This probably isn't an exhaustive list, and a few of these are probably going to need additional properties, but for now, this works as a proof of concept, because all we're really going to be doing is looking for these two mover tags. So let's pop back to the code and talk about how we're going to do that. So right away, let's nuke both of these, because we're not going to check for the name of the object anymore. And we're going to grab the components property. So here we're grabbing the components property from our object properties only if it exists. And if it does exist, we're going to want to split it based on the pipe character. So let's do that real quick. Let's just make sure we're dealing with a string here. This logic's pretty braces deep. There are definitely some things that I'd like to do differently here, but whatever. Now let's iterate through that components property splitting on pipe characters. And now we're going to do something based on this name. So for now, what we can do is check if it's mover, and if it is mover, we just insert a mover. So, okay. So now if it's a mover, it'll insert a mover. Now this, of course, is also not ideal, because now for every single component type, we'll have to have this as well as logic to parse the data from it. But for now, as a proof of concept, let's test this. And there we go. They're both moving still. And of course, just for the null hypothesis, is that the right way to use that term? Let's just try without that code at all. And now they're not moving. Awesome. So, like I was saying before, I don't really want to do this if statement. Instead, I'd like to do something like a call to a function, some sort of function. I'll call it hydrate entity, and we want to pass in those entity commands, the object that we're referencing, so that we can grab the names and as well, and the component name as well, so we can use that function to find that object. So here's the entity commands, the object, and the component name. So we're going to be calling a function like this, right? And so this functionality is going to live in a different file at the very least. So let's start with that. All right. So we're going to do this in a little bit more of an almost object-oriented approach, but that's mainly because we want to hold on to this state while we build up this list of hydrators and then act on whatever components we see in this scene to do our spawning. So in order to spawn things, we'll need the entity commands. Object data is for reference to, for instance, dir x and dir y. We're going to need object data to get those properties. And then the string here is just the key. And that key, if you are following along, is going to be mover in this case. But for other components, it'll be different, obviously. So what do we need for this? Let's implement some functions for that. Object. All right, and this is going to be a pretty basic constructor. I think I need to import hash maps. So let's do that at the top. Handy that Bevy has a hash map implementation for us. We also need a way to register those hydrators, which is to say put them in the hash map with a key. So this is going to be the mute self. If you're unfamiliar with Rust, that's just saying that this is a function that you call on an object This is just a reference to the whole component hydrators object, which includes the hydrators hash map, which we need right here. Component name is, of course, the string that we're going to store as the key for this hash map, and then the function is what we're going to pass in to hydrate with. And this is actually going to end up being called in movement, because I think it makes semantic sense in my brain to define the component and have its hydrator live nearby. Or, well, today we might not put it in here, but eventually we'll find a way to put it in here. Now we need a way to effectively reference this hydrator hash map and say, hey, I have an object data for you, please spawn it using the function that was passed into you in this function. So let's make that one. So just to talk through what we've generated so far here, obviously the self doesn't need to be mutable at this point because, oh, actually, before I talk about this function, just a heads up, we're returning self from this one so that we can chain these register hydrator calls, and I'll show you how we're going to do that later, but we're not really going to use that in this episode probably. However, this is a really neat pattern for keeping things orderly, in my opinion. But anyway, back to what we were doing over here. Self doesn't need to be mutable because we're not actually mutating anything, we're just using the function that's stored in the hash map. And again, this is the name, which is the key in that hash map, the data, the commands. And we're just going through all the hydrators and grabbing the one that matches that name, if there is any. Otherwise, we're saying, hey, there's no hydrator, which we're going to see this a whole lot when we run the project, because all we're going to define is the mover hydrator. And that's totally fine. And there we go. We call the function with the provided commands and data. And with that, hydrate components should be done. So let's go ahead and define it as a module. And now it's complaining. What's it complaining about? No entity commands in the scope. We need to import that from Bevy. Object data, we need to import that as well. Bevy-utils. Oh, Bevy-utils isn't default. We need to actually import that. So let's go all the way over to our cargo file. Haven't seen this in a minute, have we? We need to use Bevy-utils. I believe that's the same version as Bevy, but let me check. Yep, that'll also be the same version as Bevy. Now, next time we cargo run the project, it'll pull in Bevy-utils and all of its dependencies as well, which includes a nice hash map function. So that's handy. That fixes that. What else do we need here? We're going to need to define a hydrator for movement. But before we do that, let's go over here and fix this real quick. So for now, we'll just put this here, and we'll create a new component hydrator object. So that creates a new one. We're going to add some more calls here in a little bit, and then we can just call hydrate entity on that. There we go. This side of the code is actually done now, but we actually need to add that hydrator in. So let's define that in movement. I don't know if I know how to spell hydrators anymore, so I'm not even going to think about it. That's fine. Whatever, I don't want to think about it. Let's make a hydrator for the movement. But before we do that, we actually don't want a string data, we want different data, right? Because the mover needs direction X and direction Y. And we can do whatever we want with this. For now, it'll just be an IVEC2. So let's define a hydrator here. Alright, so we're inserting a new mover, which is going to have a direction. And we're going to use X and Y for that. So let's make some new properties. Let X equal object data. I actually don't know if direction is an integer or a float. Let me just check. I believe that's an integer, because I don't think I can add a 0.5 here. No. Okay, so that's an integer. That's fine. So value I. So now this pulls the dir X and dir Y directly from the properties, which then get put into the mover. So that's fairly nice. If you'll notice, the nice thing about this that I was going to talk about before is that we can kind of have our data however we want, and this is just a nice way to convert from one way to the other, because if we wanted to, instead of IVEC2, just have like an X and a Y, then all we would really need to change here is how we're assigning it here. We can also have some default values, like still have a data, for instance, and then all we need to do is just add it here, right? Basically something like that. So that's cool. Anyway, so there's our hydrator created, and all that's left to do is to register it. So now anything with a mover tag is going to use this hydrator. Now what's this mat about? Object data needs to be a reference. Whoops. There we go. So that should be all we need to get these movers moving. So let's see them move after we import all of the Bevy stuff. All right, here we go. Look at that. They're moving. And also you'll notice that it's also looking to try and hydrate colliders, exit, treasure, goblinoid, which means from here on out, it's just as simple as defining a component and a hydrator, and we can pull data from our map. That is awesome. I believe that's as far as we can really get on this episode. But next time, we will probably be making this movement look a whole lot more like the Game Jam game. That'll include referring to the actual tile layout and moving our entities accordingly so that they don't clip through walls and that they move a little faster and things like that, rather than just slowly moving them along the x-axis. But that will be an issue for next time. Thank you for watching. Peace.